Good evening, everyone. A very warm welcome to our first online meetup, which is on Kickstart with AI on Azure. I am Shubham, Program Manager at Skillenza. So, some of you might know, what Skillenza is and what do we do. So, basically, we are a challenge and a peer learning platform. So, we are a platform which allows companies to post challenges and job seekers instead of, boring job descriptions. So, the platform is divided for professionals and organizations, and so these are the rewards which you get when you come to our platform and apply for jobs or apply for hackathons. Now talking about Devengers. So this Devengers is an initiative by Skillenza, which is supported by Microsoft. So in total, we have organized around 21 meetups and 7 hackathons, which are also known as Hack Nights. So and this meetup, we are a community of 9,000 plus. So kudos to you guys. Now coming back to our webinar, it's a pleasure to have Shivam, who's a co-founder at Tech Scalable. And Shivam, I'd like you to hand over and take up the session now. And also, guys, you can tweet about your experience using these relevant hashtags. All right. We'll just quickly walk you through the process, like the flow of the webinar. Shivam will be taking up, and then we'll have 10 minutes for Q&A post his session, and then we'll have a short presentation from one of our team who has been one of our winners in our Hack Nights, who will be presenting about their product. All right. So over to you, Shivam.
Now you should be able to hear me out as well and see my screen. In case I'm loud and clear, if I'm audible, please let us know in the chat window that everything is okay. We'll start the session. Let me quickly open the chat window. Yeah, we can hear. Okay, that's great. So thanks for the introduction. And let's start. Let me quickly share my screen. And my screen should be visible as well, right? Yeah, I think that's great. So check this out. So we are starting with the session, and let me introduce myself. My name is Shubham Sharma. Microsoft Azure is one of my primary cloud, and I work with various customers with consulting and training requirements for tech scalable. And we work in the fields of DevOps, data science, architecting on Azure, AI solutions on Azure, data science, machine learning solutions on Azure. I'm also a certified trainer from Microsoft. And at Tech Scalable, we are Microsoft partners. We provide training and consulting services. And our expertise also lies in Kubernetes as well, along with ML, AI, data science, Docker, Azure, and DevOps. Just give me a second. Let me just quickly open the chat window somewhere so I can have one eye on that in case something goes wrong somewhere. Just give me a second. And it will be great if you guys can keep yourself on mute so we can have a clear audio channel. Okay, so what are we discussing today? Now, first of all, what is data science? There is a lot of times the question comes to me: is data science same as artificial intelligence? Is it same as machine learning, or what is deep learning? What's the difference between all this? I want to work in deep learning in Azure. How different is that from data science? So we'll clarify that first, and then we'll see how machine learning models are created. What is the basic flow of a machine learning model? What are the various steps over there? And we're going to check out Microsoft AI platform. What is Prebuild AI? What is conversational AI? What is custom AI? I have 2 demos for you as well. And then we'll have a Q&A session of around 10 to 15 minutes after that. Right? So this is what the agenda of the day will be. And I think let's start. So the very first thing, what is data science? Now, data science is something which is, you can say, multiple disciplines are there, and it combines domain expertise, programming skills, knowledge of mathematics, statistics, and basically you have to extract meaningful insights from the data. As a data science practitioner, you will apply machine learning algorithm to all sort of data, maybe structured, maybe unstructured. For example, like you will have text with you, numbers, images, audio, video data, and you have to create artificially intelligent systems. What are these artificial intelligence systems? These systems are what mimic human behavior. And as an analyst as a data science practitioner, you will extract this information, which will be like a business value, and from raw information. That's what data science help us do. So let's talk about how much data do we produce every day. Is data science a field which is gonna last for a long time, or is data science just like it will be popular for just a couple of years like that? Let's just understand how much data do we produce. I have one report. I have this infographics from Recontor over there, and this infographic, all the statistics are from 2019. So, and everything is happening in per day as such. So we have 256 billion emails in one day. Uh, that's what's sent every day in 2019. 500 million tweets were sent every day. 4 petabytes of data was created on Facebook every single day by the users when they uploaded their images and other content. 65 billion WhatsApp messages were sent every single day in 2019. 96 million photos were shared on Instagram. 28 petabytes of data was generated from devices such as Fitbit. 3.5 billion searches were made every single day through Google itself. Around approximately 463 exabytes of data will be generated every single day in 2025, next 5 years. Exabyte is something which is having one followed by 18 zeros as such. It's a huge number. So, let's say data science is a field which is going to last for a long time. And along with IoT becoming so popular, huge amount of data is being generated. And as a data science practitioner, what are you supposed to do? You need to have business understanding. You need to have domain expertise, understanding of cloud technologies, where you can perform data science, where you can apply machine learning algorithms. Knowledge of databases must. Data science, data engineering tools are required. ETL transformation tools, programming skills are a must. Big data, Spark, Hadoop, they go hand to hand with data science as well. Mathematics, statistics, it's very important to have a problem solving acumen, and definitely a knowledge of machine learning, deep learning, and many more fields. I might not have them in the screen, but there are many more fields which you require to have understanding of, to extract the information from structured or unstructured data. So now coming over to what is AI, what is deep learning, what is machine learning. Now, artificial intelligence is, I can say, AI techniques. They enable computers to mimic human intelligence, which include logic and decision making. Machine learning, it's a subfield, or you can say a subset of AI, where statistical methods are used to train the models, and these models, they improve with training and experience, and they start mimicking the human behavior. What is deep learning? Deep learning is a subset of machine learning, where neural networks comes into picture. Multi-layer neural networks are used to train the solutions. So this is a little bifurcation, and this is a little understanding of how AI, machine learning, deep learning, they stand into place. Deep learning is something which is very useful. It's something which has given us a lot of recent uh, breakthroughs, and a lot of value has been added to the machine learning world using with deep learning itself. For example, name entity recognition, object detection, image caption generation, machine translation, text analytics. So what are these? Let's have a quick understanding of what are these. So we'll get a little understanding of what use cases are there. Apart from these, many more use cases might also be there. I might have just noted down a couple of them over there. What is named entity recognition? Now, named entity recognition is the process where one algorithm takes a string of, you can say, string of text. Maybe it's a sentence or a paragraph as input, and it identifies the relevant information like people, places, organization, dates, some sort of value over there, which is mentioned in that text. Why do we do that? We extract this information and we use this further in chatbots and so on and so forth. We have many use cases in natural language processing for this. Object detection is something which we all have seen before, which we all have this picture which I have, maybe you might have seen similar pictures before. And it's already used in gaming, retail, tourism, and self-driving car. So in various industries, we already use it. Object detection, it comprises basically of two things: image classification, then image localization. So image classification is like identify the object, like where is a person, where is a car, where is a lamp on the table. And image localization provides the specific location of these objects. So where exactly they locate. What is image caption generation? Just like you can see on the screen, Mr. Satya Nadella is wearing a suit and a tie. So generating what is going on inside. So it's a caption generation. So whatever is going inside the image, or maybe in video, we can also apply that. Whatever is going inside the image or the video, that can be a summary of the image, or a caption of the image, or uh, a summary of the, or an index of the entire video can be generated. That's what image caption generation is all about. Machine translation is also one a bigger field. In machine translation, you can convert. Real-time translation is possible. I'm speaking in English, you are hearing in German, and so on and so forth. These type of translations can be done. Text to speech, speech to text, and so on and so forth. One language to another language, automatically we can translate. That's what machine translation is. And this is something which is very important as a breakthrough in deep learning. Text analytics, every single company, they do social media sentiment analysis, and to know what people are speaking about their products. If people are speaking positive, that's great. If people are not speaking positive about the product, then basically we open the ticket and the customer care team goes and try to resolve the grievance. Now, another example of this can be insurance fraud as well. Now, text analytics are all, you can say, often applied by insurance companies to recognize the chances of a insurance claim being a fraud. So text analytics help us in various fields like that. So these were just a couple of examples as such to give you a understanding of what deep learning provides us. And now let's understand from the point of view of a developer, let's say, what is the difference between a traditional programming versus what is machine learning. So once we can differentiate between them, we can further check out what machine learning offers us. As a traditional programmer, what do? We provide we have the data, we provide the rules, and we get the output. We are basically hard coding the behavior of the program. In machine learning, it doesn't work like that. We provide the training data, input data or training data, and we provide the outputs. And along with the outputs, we also have an algorithm which is learning or which is training. What it is learning some rules or some patterns from the data. So in machine learning, a lot of the final rules or the weights which are decided, we leave it up to the machine to learn from the input data. Once these rules are learned, right? Once the rules are learned or the weights are learned, then what do? We take these learned or we take this trained model and we deploy this. We first test it out with unseen data. We pass some data which is not seen before by the model. So we test it first, and if you can say if the model performance is satisfactory, we deploy this in production. We open the endpoints and then we start using the model as such. So there's a little basic difference between traditional programming versus what machine learning provides us, or what do we do with machine learning. So how does the modeling happens? How do we basically make any generic machine learning model? What is the flow of it? That's what we are talking about. Now, so it all starts with the data. We prepare the data. You have raw data. You will apply pre-processing tasks or scripts or steps on the data. And when you have the process data, which is cleaned enough, which is satisfactory enough, we apply various machine learning algorithms to it. Now, there are hundreds and thousands of machine learning algorithms. So a lot of time what happens, we are not able to identify the best model. As such, we have multiple models with us. We call them candidate models. We have multiple with us. And then with the help of testing, we find the best one out of it. So you apply multiple algorithms, you have multiple models, and then you find the best one out of it. And if it is satisfactory enough, we put this into production and we expose APIs and we start using it basically. So what are the various, this is a basic flow of any machine. I think guys, just put yourself on mute, right? We can still hear some background noise. So this is the basic flow of any machine learning model, all the steps which are there: prepare data, training model, testing model, and operationalization of models. So what are the tasks which machine learning help us do, right? What are the various tasks it can help me do? One thing which it can do is anomaly detection. So we can find the anomalies in the data. So for example, the credit card companies, they track your purchase pattern. Why do they track your purchase pattern? Because when they find that, okay, you are trying to access, you're trying to do a transaction from which is not which is not very common for you, which is not as per your pattern, that's an anomaly. So they notify you that, okay, some sort of fraud might be going on. So credit card fraud detection is an example of, let's say, anomaly detection. We can also do classification with machine learning. What is classification? Spam versus not spam email classification is a very common example. Not spam is called as ham. So spam versus ham email classification. Should it go to the mailbox, inbox? Should it go to the junk folder? All that we can do with it. Or we can also answer some other questions. For example, let's say I ask a question that which will bring you more customers? Will it be a coupon or a discount? So if your boss comes and asks that, okay, what will bring us more customers? Should we give a coupon or a discount? So you have to find that which is better for your company. We can also do regression analysis. Regression analysis is all about finding the numbers, numeric predictions. And for example, we can do, let's say, what's the temperature going to be next Tuesday? What is my sales going to be in the fourth quarter? Which is a very relevant question for this year. What's your sales forecast? So numeric outputs, which what we get from regression analysis. We can also do clustering. Clustering is somewhere, for example, let's say which viewer like the same type of movies. If I am in the same cluster as you and you have seen some extra movies which I have not seen, then those can be recommended to me. They will be recommended to me in Netflix, they will be recommended to me in various platforms altogether. So clustering algorithms can be done. There are many more families, I have not listed them. So reinforcement learning is something which comes to my mind. So there are many more tasks which we can do, but this is just like an introduction to various tasks. As such, the most popular family of algorithms, and each family of algorithm will have hundreds of algorithms as part of it further, right? So now let's come to, so this is little basics, or you can say little understanding of what is data science versus what is machine learning, what is AI, and where do we stand. Now let's talk about what Microsoft Azure provides, right? What are the various solutions? What are the various offerings? A lot of these you might have already been working on. And if you think of making a career in AI with the help of any cloud platform, Microsoft AI platform is one of the best ones as such. So what are the various offerings? There we can bifurcate, we can differentiate the offerings in three sections as such. We have pre-built AI solutions, conversational AI is there, custom AI is there. So pre-built AI are more developer oriented. Conversational AI is also developer oriented as such. So what is pre-built AI? Pre-built AI is something where uh, models are already trained from Microsoft. We have 28 type of different cognitive services. I'll just cover one of it. And for the other 27, you have to come for the upcoming sessions as such. So what are pre-built AI? So these solutions are already created by Microsoft. They are, you can say, world-class, as good as they can be. We just customize these solutions for our requirement, expose the API and integrate them in our products and start using it and make smart products like that. What is conversational AI? Conversational AI is where we create chatbots. So these chatbots will be having various channels. Channels are from where the customers are talking to it. And these chatbots, to be honest, they are not very smart as such. We bring in the smartness along in the chatbots along with the pre-built AI. So we integrate the bot services of Azure with cognitive services or custom AI solution, and we bring in the smartness into the chatbots as well. As part of custom AI, we have Azure Machine Learning Service, which which integrates everything altogether. We'll see that. Now, what else Microsoft AI platform provides? It provides you location where you can keep your data. So in case you have a requirement that your data is scattered throughout the globe, or you have customers, it's a distributed database, your customers are throughout the globe, you require some sort of planet scale database which can sync in milliseconds with each other. the nodes can sync with each other, you can go for Cosmos database. So that's where our data will be kept as such, or maybe served from there as such in the front end. MySQL and Postgres are obviously there, and you can keep your data inside that. Azure SQL database, platform as a service offering also, or maybe it's infrastructure as a service or managed instances can be used. Synapse is basically a warehouse, so you can keep your data inside the warehouse. And data lake is something which is a Hadoop file system. It mimics a Hadoop file system, and it doesn't have any upper limit. So even if a company doesn't know, let's say, what to do with the data, we don't throw data anymore, we just keep in a data lake. One day we'll have data scientists, one day we'll have developers who will create smart applications with that data as such. Now, if I create custom AI solutions, so if I create custom AI solution and I am working with huge amount of data, maybe I'm applying some deep learning algorithms, or some sort of something which a lot of steps are there. I require a platform which can provide me huge amount of compute. So you can train your models on Spark. You can have Spark clusters. You can have data science virtual machine. What is DSVM? DSVM is a ready-made type of virtual machine which is having everything which you require for data science task or for running your AI or ML solutions. Anything which you require will be already installed in data science virtual machine. We also have Databricks. Databricks is a Spark offering, and Databricks cluster is something which is extremely popular and is recommended to use when you're training your data custom AI solutions. It's zero management Spark solution. Once your solutions are trained, you can also deploy your solutions into Kubernetes services. Now, if you use Azure Kubernetes services, you get the integration with every other solution of Azure. So everything comes into one picture, and it's highly scalable as such. And in case you don't want to go for Kubernetes, you obviously have ACI with you, container instances, and we can also deploy these solutions as web services. And AI solutions can also be deployed into the IoT edge devices. So we take the AI to the customer, and even if there is no internet, the scoring or the outputs are coming locally on the IoT devices like that. And the platform is powered by CPU, FPGA, GPU. CPU and GPU, I think we all know that. FPGA is basically what that is. You can say it's application specific circuit are there. They're called as field programmable gateway arrays, and they can be reprogrammed for some particular task, like processing the tensors or processing a specific type of algorithm or processing or doing hashing and so on and so forth. Those are FPGA. What else is there? We have Visual Studio Code. Now, VS Code is one of the go-to, you can say, editor for data science now. Azure Machine Learning Service will also provide you graphic designer. We'll see that. And the management of the machine learning solutions can be done with the help of a machine learning workspace. A workspace is just like it's like a wrapper around all the various things which you have in your experiment. You might have trained models, you might have your data set, you might have data stored, and everything will be in one place, which is called as a workspace. You can obviously use Jupyter notebooks, and you can bring in any other editor as well. You can have PyCharm and so on and so forth. Any other thing can also be used. Deep learning frameworks, third party are also supported. TensorFlow, PyTorch, scikit-learn, AmXNet, Keras, Chainer, Gluon, and it's a open. Microsoft Azure AI solutions are open for any other framework we can import, just like we do it locally as well, and we can start building solutions with it. So let's see this happen. Let's instead of all this theory, let me just show you how does it work. So let's talk about pre-built AI solution first, and then we'll see further. Just give me a second. Let me just bring in a new screen altogether. Okay, check this out. So imagine, so let's say we have a art collector over here, and this art collector is purchasing a art obviously, and there is a dilemma that this art collector is in. He's purchasing a picture which looks like Picasso's offering. However, he's not sure that whether it's a real painting or a fake painting like that. So he comes to you, he says that, okay, can you please help me out with this? So what do? You train this model. That's where you come into picture, and you train this model. How do you train the model? Let's talk about that. So you gather the data set, you gather Picasso's real paintings, or these are originals, Picasso, Pollock, Rembrandt. We have three painters in the data set. And you take these data set and you train you train a pre-built AI model. You basically customize the pre-built AI model for your own use case. To be technically correct, we do a thing called as transfer learning over here. And these models are now customized for our own use case. We'll see that happen. So we train this model using custom vision cognitive services. This is the only one which I'm covering, and there are 27 more. You have to come for the upcoming sessions where we'll talk more about every single service as such. Once the model is trained, you can deploy this model in the cloud itself and expose these model with APIs. So you can do an API call to the model and the score will go back. Score means like whether this is a Picasso's painting or whether this is Pollock's painting or whether this is Rembrandt's painting or not. Secondly, we can also, so in case this art collector tells you that, no, I don't want a solution which requires internet connection all the time. Can you give me a solution which will work even if I don't have a internet connection? Just like in iOS, we open for example, I open my laptop with my face. The cell phones, we open them with our face. So even if there is no internet, it should work, right? So we can also download this model and train model and deploy locally. So let's see this. How will this work? So let me keep this open. Let me bring a new, uh, let's say, okay, something. Let me just quickly get it over here. Check this out. I have a couple of backups with me in case nothing works out. We can obviously show the demos from here. But let's create that fake painting or not again. How does it work? So basically, where am I? I'm in a, let me show you where am I first. This is called as custom vision. It's a different portal. Is it Azure Portal? No, it's a different portal. But whatever you create over here, it integrates with Microsoft Azure and we see everything in the Azure portal itself. So if I create something here, everything goes into Microsoft Azure. A resource group will be created over there and everything will be there as such. This is a nice looking UI which you can use, and we can work with Python as well in case we want to create these pre-trained models. So let's say I click on new project and fake or not painting 2. All right. Uh, I have already created this custom vision endpoint. What is this? This is basically an Azure portal. Uh, they have already created one API endpoint for me, which will be where I will also pay. The billing will be there done as such. And also the API call will go to that endpoint afterwards. So we have two type of projects. We have classification, we have object detection. Classification is what we are doing right now. And object detection is more like finding the lamp on the table, right? So classification, and we are putting multi tags per image, and they can be single tag per image. Uh, what are these domains you see over here? We have general, food, landmark, retail, general, compact. What is this compact asset? So in case you want to download the models afterwards, you have to create a compact project. Otherwise, you can create a general project. So I'm just creating the compact project right now. So I can download the trained model as any other model as such. Like I can download a TensorFlow. I can also download it as a core ML or ONX model, or maybe I can download this and deploy on a Microsoft Vision AI Dev Kit, which is like a camera you might have seen, which Microsoft now offers, which we can deploy locally, right? So let's create this project. Just basically clicked on it, right? So now what I'm doing, let me quickly, uh, okay, so some tags, I'm creating some tags. What are these tags? What am I creating right now? So you are supposed to train this model, right? So you have to provide the real images for the training purpose. So it can learn the rules of how a original Picasso looks like, what is the pattern in which he designs, what is the strokes which he takes, uh, how is this brush strokes over there, how is the movement what a color combination is being used, and so on and so forth. So basically you have to provide the original images, and so for that we require some tags as so that this is Picasso's picture and that's and so on and so forth. So I'm just giving some tags. Do I have to do this manually? What happens if I have 1000 uh, tags to upload? We can simply do it with Python. You can, in a loop, we can upload that. So UI is you might use UI less once you start using it. Just it looks very good over here, so I'm going to be just using it. So let's say Pollock, that's our second painter, and we have Rembrandt, and I'm adding one more tag over here, painting. So our classifier will be basically who's painting and is if it is a painting or not, like that. Let's add some images. I already have the images with me, and this is not the correct folder. So let's go to the correct folder, and I have Picasso's pictures over here. So I'm just adding these Picasso. I'm just uploading these pictures. Uh, how many pictures do I need? Basically, you can say 5 to 6 pictures. Uh, Variety of pictures are needed, like that. So this is Picasso's pictures getting uploaded. Let's add a couple of other pictures. Now I have these originals from the other one is Pollock. Let's put him as well. So we are basically creating that classifier, right? It's a fake or not. One of the good things which I like about this classifier is that it also detects the pattern of the person, how he works with it. So this is Pollock's, uh, and that's the second one. And let's add more images. If I have thousands of images, you cannot do this manually, right? So you in a Python loop, we can definitely do that. This is Rembrandt. So 3 painters, their paintings we are uploading, and we're just putting some tags that whose painting is it. And let's do it quickly. Let's just carry on. So click on done, and I'm clicking on this train option. We have 2 type of trainings. One is quick training. Obviously, we're going to do that. In advanced training, it's going to take us 1 hour and beyond that till 24 hours, like that, for the training purpose. What extra happens in advanced training? They do a thing called as hyperparameter tuning. They do a thing. They optimize my parameters better. The learning is better. More iterations are done, and so on and so forth. So right now we are just doing quick training. Let's click on train. So a machine learning model is getting trained right now. It will take around 30 seconds for it to train. In the meantime, afterwards we can click on this prediction URL. And prediction URL is where once the model has been deployed, the API endpoints you can copy from the prediction URL endpoint. And afterwards, if you click on the export, is where you will find the files, like you want to run this locally in the iOS app. So you can click on the iOS option and it will download and we can run it over there. We can download in an Android as an Android compatible model as well. And the versatile inside a Docker container, we can do that. So something got trained, right? Let's have a quick test. Let's check this out. How does it look like? So now we are going to provide, and let me just quickly show it to you. So let's not provide an image which we have already given, right? So when the art collector he goes, he should be able to, even if someone claims that this painting is from Picasso, we should be able to, or the model should be able to understand that this is Picasso's way of painting, color combination, and everything like that. So this is the existing data set. Let's upload which is something which is not there. So we are going to do a quick test with a image which is not as part of the data set which we have already uploaded. And let's go back and let me go to the other folder. I have already kept some images separate. So this is Picasso. I know that this is Picasso. The label is not, doesn't matter as such. So and the model is also saying that this is a painting, which we know that's a painting, and it's a Picasso's classic. So it's 99% probability is there. It's Picasso's painting. It's not zero. These Rembrandts and Pollock is not zero, but it's so near to zero that it's shown as zero over here, right? If I do a quick test with something else, let's say I upload. So this is a picture I have Googled from of Switzerland. So if you don't give a painting, this is a real picture, a camera snip. So it tells you that this is not a painting. I'm just 2.5% probability that, so probability is only from, you can say 0 to 1, right? But in percentage, I can say 2.5, like that. So 2.5% probability is that this is that this is a painting. So we can now see that it's not a painting, it's uh, a real scenery altogether. So this is one thing. And even if you upload some other painters painting over here, it will tell you that, okay, this is a painting, we are sure it's a painting, or more probably that it's a painting, but it's neither of the 3 classes which we have. It's somebody else's painting. So the art collector will be very confident in purchasing the painting now, that okay, this is a Picasso's original painting, it's not from someone else, and everything else checks out, and now we can negotiate on the pricing and so on and so forth. So this is how quickly you can create a custom AI solution. How will you deploy this? So you can simply click on performance over here, publish this endpoint, fill up this one page, click on publish, you will get the API endpoints where to send the API call. And in case you want to download this, you can download as a core for iOS. You can click on this option. For Android over here. Versatile Docker file, you can click over here. Onyx is these are open neural network exchange models. It's a new concept in which the models can be converted into various formats. And you can definitely use this along with Microsoft Vision AI Dev Kit as well. So you can just click on it, it will download. So if I click on this, it will tell me, do I want to run this in Raspberry Pi or Windows or Linux? And I can simply click on the version and I export it. So once it's exported, I can deploy it locally, right? This is something just to give you an idea of how does it work. Now, what happens? Uh, can I have a different use case altogether? Check this out. So basically over here, I have a different use case where you are creating a face classification for your company. So as an employee, right now in most of the companies, we are swiping the ID cards and then the gate open for us, and then we enter in the company's premise. Why doesn't you create a face identification solution for your company? So when the employee comes in front of the camera, there is a, so if I just zoom in over here, there is a camera over here, and behind the camera there might be a server, or there might be a Raspberry Pi device as well. What is Raspberry Pi? Raspberry Pi is the micro computer, and basically we can have a OS over there, very lightweight in nature. So we can train the model in custom AI, which is only one type of cognitive service, right? It's an example of pre-built AI solution. We have 27 more types, which in upcoming sessions you will see. So this is not the only thing which exists. There are 27 other types of uh, pre-built AI solutions, which are in various other fields. So we can train the model, we can deploy this in the server itself, or we can just deploy in the cloud as well. So how will you get the data? You can get the data from your HR team. Maybe that is the most difficult part of this solution. You will have the various employee data. So I already have this created. So the steps are same. You already know that how to do it. What you can do, you can just take your own selfies and you can do with your selfie. Just make sure that the background is a different type of background is there. And so as an employee, what we have decided, let's say in your company, you have Ben Affleck and Robert Downey Jr. as your employees. So we need variety of data as such, various backgrounds, maybe hairstyle, with specs, without specs, and Ben Affleck's various images as such, in some of them with beard, without beard, and so on and so forth. So this is what you will get from the HR team, various images all together. And you upload them to custom vision, you train your model. And once the model has been trained, you can just deploy this as well. And let me just show you a quick test, right? So let's say we do a quick test right now. How does it look and feel like? So if I go to the different folder where I had this information, there is a testing folder. So let me quickly show this to you. So we have uploaded these images of Mr. Robert Downey Jr., these images, right? There is nothing apart from that. So, and in the testing image, we are totally providing something which is unexpected or unseen data. In what terms? So imagine your employee is wearing a fancy dress costume that day. Maybe he's wearing an Iron Man suit and so on and so forth. So he comes dressed like that. Even then we can find that this is Robert Downey Jr. And this tag I have put for different purpose. This is not Ben Affleck. So Ben Affleck's probability is actually near to zero. It's not exactly zero, but this round it off to zero as such. So even if the employee is having some bruises on the face, or is wearing something else, it will be able to tell you that that's the same person. And now if the person is same, you can open this door, you can demagnetize that door, and the person, you can mark him attendance as well, and so on and so forth. And you can let him in like that. So this is what custom AI solution looks like, how quickly you can create a basically how you will be able to uh, just uh, you can say customize their solution with for us and start working with it, right? Now let's talk about what other families are there. We have decision family, speech family, language family, vision family. I was showing you one of the examples from vision family. And search family is there. These cognitive services family are there. In each family there are multiple type of cognitive services. To learn more, join us in future, right? Now let's move further. Let's check out what is custom AI. So Now, what will happen in case your solution is something different? It's not which is pre-built by Microsoft. It is something which you have to custom create. Then how do you do that with Microsoft solution? Check this out. So what your use case might be. So I have this diagram I created over here. So maybe you have to, let's say there is a company called as sellcar.com. It really also exists. So there's a company such as example, let's say yoursellcar.com. And what is going on over there? There is a seller, and the seller, he's selling the uh, various type of cars, and the buyer, he goes and he pick up these cars and so on and so forth, he purchases all that, right? So there is a solution like that. Front end is there, and your solution, your car business is there where you are selling cars, right? So the seller, from his point of view, will always ask the maximum amount. He will not give you a fair market price. He will always maximize his. He wants to sell on the highest cost as such. Buyer wants to purchase on the lowest cost as such. They will negotiate and will settle on the best cost. So to help the buyer make better informed judgments, what you are gonna do, what is your use case? So where are you over here? So you are over here on the red side, on the left side in the red phase, right? So what do? You create, so using the specification which the buyer is uploading, for example, which brand car, wheelbase, length, width, height, weight, engine size, bore, stroke, compression ratio, horsepower, and XYZ, right? So whatever he's uploading, and his price also. So what you have to do is you have to create a more custom machine learning solution where you will be able to figure out that, okay, for this year of made, for this model, for this specific car, the fair market price is this. So in your solution, you might be there will be a asking price from the seller, and there will be a sort of fair market price, so the buyer can make an informed decision. And once he knows that there is a fair market price, he can further do negotiations as such. So this is a solution which most of the companies which sell cars and any other thing, they provide. So how will you do it with Microsoft Azure? So you basically have two options. You can use your favorite programming languages, Python or R, to create models. You can use scikit-learn, you can use TensorFlow, PyTorch, Keras, and so on and so forth. This solution doesn't require deep learning as such. We are happy with the scikit-learn also, but everything is supported as such. You can use Jupyter Notebook, VS Code, or you can use a visual designer as well. In case uh, you don't want to reinvent the entire wheel, you can use a visual designer, and you can design your solution, and you can deploy the solution into AKS, ACI, or any web services in Azure, wherever it's suitable. And from where we are doing the scoring against the model. So how is this done, right? What is the service which can help me do this? Let me just quickly get the browser. Check this out. Just give me a second. So I have this over here called as machine learning service. So I have already created the endpoint. How did I create that? I just clicked on this create a resource. I just searched for machine learning. Let me just show it to you. So I searched for this machine learning and I just clicked on it. The first option and the first option, this one. So that's what I have over there, the machine learning workspace. So what is this workspace all about? What are the various options? What are these options over here? What is this experiment, pipeline, and so on and so forth? So experiment is something, for example, you might be doing something in classification, regression, and anomaly detection. So you might have 3 experiments with you. Pipeline is the, in one experiment, whatever you are defining, the entire, the flow we talked about, right? The machine learning flow, that entire flow uh, and more as well will create the pipeline for you. Compute is like various type of computes are available. These computes are available for the training purpose, and uh, for, you can say, when I train my machine learning solution, this is where it trains altogether. So I can provide Spark oriented compute. I can provide DSVM over there. I just have a VM right now as my compute cluster. We can create a Spark cluster over here, 50 node Spark cluster, and things will happen on a lightning pace. So once everything is trained, I click on, my models which are trained, you see this model, for example, what do I mean by that? So I train something over here, and now I have to operationalize the model. So the model, we save it as a pickle file, .pkl. So that model has to be just like we have code repositories. We use version control. We have repository. We have Git. We have VSTS, GitHub, Bitbucket, and so on and so forth. So we also have in data science or AI or ML field, we also have a requirement of model registry. We need to have various versions of models. So I am making one version today, tomorrow a different version. Then we are doing a rolling update of one more version and so on and so forth. We need to manage that. That's all is managed over here. Image can be created out of this. So images are Docker images over here. And the images, one of the good part is that you are packaging the model along with any dependency as such, and any other file required for the API calls. So everything is as part of image in one place. So package can be quickly deployed, and deployment targets will be AKS, ACI, web services, or VM, or any other custom solution. You can download anything. In case you want to run it locally, you just click on this option, download the image locally. So all this is part of what Cognitive Services provides. Anything which a data scientist require to train his models. So I'm using over here, let's say click on overview. I'm using a new interface which they have created, which looks like this. It's the same thing which is over there. Slightly, you can say a little better UI. So let's click on this. So notebooks. So I created one notebook, and it opens like that. I can click on this edit option and edit in Jupyter. So if I click on that, it basically opens the model over here. So this is where you will define and your entire workflow. You can get your data, you can load, you can break the data into test, train, sets as such, and you can apply various type of, you can get various type of algorithms from various libraries. You can import them. Even if something is not by default available in the ML service, you can just import that particular library. So the training happens. This is where I have a Python notebook and I'm doing the training. And once I do the training, I can have my model as well. So this is a trained model, something .pkl, model alpha.pkl, right? So this is the model which I will in future will be deploying over here, which I trained into this location. Guys, just put yourself on mute, right? Check this out. What else do we have? So we also have a designer available. So what's the meaning of designer? Let me just show it to you. So designer is somewhere you can search for these modules on the left hand side, and you can drag and drop these modules over here and make your design of the entire thing. If and this the designer make it very easy. For example, if you are sure about what you are doing on a piece of paper, if you can reason it out, you can create that entire thing over here in within minutes or like that. So how do we visualize this? So everything still remain the same. Guys, just put yourself on mute. And so if I click on this options, we have the visualization in the portal as such, and with which I can see what my data looks like, what type of columns do I have to select, what is the missing data. I can clean that missing data. Various approaches are available. We can train the data into trainings. Training data will be there. Training data is something with which we train the model. And with the testing data is where we are doing the testing of the model, whether it's working good or not, right? If it's not working good, we change the approach we train a different thing. Algorithms can be selected from here. And if you don't see any particular type of algorithm, you can simply drop a script module, and you can import your own algorithm in the same flow. So if I define what's a pipeline right now, this entire thing you see on the screen, right? That's one pipeline. So this entire steps which I have dropped over there. So this is where the model training is going on, and I didn't want to click on that. So scoring is going on over here. So scoring is where you will get some outputs. Let me quickly show it to you. So this is where you can click on model visualization, and you will see that, okay, this is the model's output. Whatever your model is predicting on the unseen data, this is that output. Uh, you remember we had one diagram where once the model has been trained, unseen data will be passed through it and some outputs will come. So this is that output which is coming, this column over here. We have enough logs. Let's just close it right now. You can come for the session on custom AI, right? We will discuss far more things over there. So evaluation of models, these are regression analysis, and right now may not be that relevant, or I might not be able to cover all of them, but goodness of the fit, how good your model is doing and everything, all the matrices. So what is the usefulness of a matrix? See, if I create a model, how will I tell you that it's doing good? You will come and you will say, Shivam, okay, if it's a regression model, tell me the R squared value, tell me the coefficient of determination. By these type of matrices, you will come to know that whether I did a good job on the model creation or not. So these are those values. So we can deploy this as well, and you can just say submit, train it. So this is a designing of it, right? It's not training. So once I say submit, it starts training on the training cluster which I have there. So training cluster might be a Spark cluster, Databricks Spark cluster, maybe 50 nodes, 60 nodes, 100 nodes, like that. So this is a toy data set, but even if you have a huge data set, a Spark cluster of 100 nodes will eat through that data set very quickly, and will do wonders on it. We can publish this as well. Publishing means that it publishes a more endpoint, and we can start working with it. One of the thing which I like about Azure machine learning is automated ML. What is AutoML? AutoML means, so as a data scientist, what happens a lot of times, we don't uh, you can say we don't have the time, or you can say we are not able to try all the algorithms. Basically, just want to put it like that. We are not able to try all the algorithms. We are not able to try all the approaches. We think that, okay, maybe that approach, if I would have used, it would have done a better job, right? I'm not sure. So what I can do, I can make this AutoML. I have not configured it, but we can make this AutoML job, and using this AutoML job, we will be able to uh, what will happen basically. So if I say, okay, this is my data set, run classification algorithms on it. So Microsoft Azure will run around 20, 30 micro classification algorithms. It will do all the tuning of the model, best of the class, hyperparameter tuning, and so on and so forth. It will take care of, there's a thing called as hyperparameter tuning. How do I define it, right? I think I have used it 2, 3 times now. Just if you're wondering, let me just define that. So what is hyperparameter tuning? Let me reduce the complexity of that. So we all have seen the radios, right? The radios which have the knobs on it. So imagine the radio is having some sort of configuration which is done inside the radio, which is we call as model parameters. Like, so in terms of machine learning, there is an algorithm. An algorithm is having parameters and hyperparameters. So parameters are like which is already preset, which are already designed by the data scientist, the researcher who developed the algorithm. And hyperparameter tuning is more like those knobs you have on the radio, which you can further use to tune your solution. So all that will be, it's very tricky, but AutoML will be able to help you with that. It will do the iterations for you. And it's not, I'm not saying that AutoML solutions are you can say 100% perfect, but they give you a good starting point. You can download the runs, you can rule out basically what doesn't work. So this is just like a look and feel of what custom AI looks like, and how can I create my custom solutions with help of custom AI. I can use my favorite programming languages, IDEs, and I can have a pipeline created around that. So this is what I have for custom AI. And I don't have a, we can say, what is conversational AI? We don't have a working demo of that. You have to come for it. It takes time for the walking through the entire steps. However, you have to come for the upcoming session, how to learn how to create a chatbot. What is bot services? Now, bot services, you can use .NET, you can use Node.js, you can use Python as well now for creating these chatbots. So once the chatbots are created, we integrate them through or with multiple channels altogether. So what are these channels? Channels means uh, so wherever my customers are, those are my channels. So my customers are on Facebook, my customers are on Skype, they're on Slack, they drop me emails, they are on my website. So if they're on my website, I use direct line API integration, and I can integrate my chatbot with my customers. Now it depends on you, what do you want to create. You can create a chatbot which is if someone says I want to see dog pictures, the chatbot might be able to, and using a custom vision, using a vision API, cognitive services, it will do a it will find the from your storage account, you might have hundreds of images or thousands of images over there which are already analyzed. And when the person says I want a dog picture, so basically we just fetch him a couple of dog pictures over there. So captions of what is going inside the image and whatever we talked about, everything will come into picture, and we can create a bot for our customers to use. And we can do speech bots. The first people can speak as such. It can type as well. You When the response comes, you can convert the response into speech, and you can play it back to the customer in case we have a requirement of we need hearing aids. So we can do that. Now, uh, so Azure Bot Services provides the SDK, and the smartness comes with cognitive services or custom vision solutions, and that's all together as part of Bot Services. To learn more, you have to join us for the conversational AI solution as well, and we'll discuss further about how to create a chat bot, how to create a water flow dialogue over there, uh, how to enable all the services. So this is a basic overview which I had of kicking starting, let's say how to kickstart your solution AI journey in Microsoft Azure. And hopefully you guys sort of have questions as well. So if you have questions now, we are open for questions. So we are keeping around 10 minutes for the questions. So if you have questions, please let me know in the chat window. It's good if we just put the question in the chat window, right? Because if we start speaking that we have a lot of people,
Uh, yeah, Shivam, we have few questions.
right?
So we have one from Karthi. Shall I drop in again in the chat window?
Yeah, just give me 1 second. Yeah, you can please drop in the chat window again.
Yeah, I've done it. Quickly.
Okay, so we have a lot of questions, right? Uh, let me okay. I'm relatively new to AI field and currently have more than 5 years of experience into .NET. While switching a job to AI/ML or in fact any other technology, then the employer is asking for real-time experience in those fields. How to bridge the gaps? Now, so for you, the starting point will be something like a pre-built AI solution, which will be the place where we need not have that much of expertise, but we can show our skills as a developer by integrating those AI solutions in a product which we can create. And I understand that basically this question is asked in every single training which I give. So the answers for this is basically see, AI and ML is something which takes time to learn. Maybe 6 months, maybe a year, maybe two as such. So start from maybe Kaggle competitions, maybe pick up a Kaggle competition over there. You have to start your journey from somewhere. Enroll into any of the competition which is going on, and slowly build your profile. Uh, Clear Microsoft also offers certifications as such. So they will definitely let you uh, in the interview. And once you are inside the interview, if you have knowledge, you can definitely crack the interview like that, right? So Kaggle is a good place. Start from there, and just start building the models. Just jump into it. While testing the model, how can you give the affirmation to system that prediction probability is correct, as the testing might be wrong? We just saw the system showing the probability numbers, but not asking if the prediction is correct. Mm, while testing the models, how can we give the affirmation to the system that prediction probability is correct, as the testing might be wrong? Okay, so Acha. Now I didn't cover that, but we have a thing called as supervised learning. So in supervised learning, what happens? We already know the answers. So see, let's say if I have to hire you in as, and for that I take your interview. So what do? I ask you questions, and I already know the answers of those questions. So if you tell me the right thing, I know this person is telling me the right thing, and I will hire you as such. So these models in supervised learning also will do the same thing. So in during the testing phase, we know what it is supposed to classify that as. And if it is not doing that classification correctly, we have done something wrong, and we'll definitely go and modify we'll tune the model, we'll make sure that it does the right thing. So we have a thing called as supervised learning, which where that is taken care of. It is little more difficult in unsupervised, where we also need a human intervention to check out that. Is there any free Azure services for Azure? Yes. So now I don't know the entire answer for that
Uh,
because yeah.
yeah, Shivam, I've dropped in the link for this. So Sheila, I've dropped them in private. So
Okay, that's great.
yeah.
And for others as well, you can create a free trial of Azure and you can start working with it. They provide you $200 upfront as such, and you can use all Azure services. So it's very easy to learn. And MS Learn, let me quickly show this as well for everyone. So those who are interested in learning uh, the technology, just go to this website. It's one search away. Let's say MS Learn, the first one. And in the browse parts, click on here and search for anything which comes to mind. Let's say machine, or you can click on products as well. And once you click on products, you just have to find machine learning somewhere. Great. Now these are various following self-following labs which Microsoft has provided, and even the subscriptions are provided to do the labs along with it. So it's totally free of for you like that. And the other link is there in the chat window. You can definitely go through that. Okay,
Uh,
so
so Shivam, just one more question on YouTube. There's some guy asking for DP100 exam. Is it enough to know only the basics of ML?
so the DP100 exam, is it in a, so can we clear DP100 exam if we have basics of ML? Is that the question?
Yeah.
So DP100 is DP100 is a, you can say, top-notch certification as such. Not many certifications are there. I'll be very honest. Let me be let's say honest over here. Uh, so DP100 is for existing data scientist, uh, and the certification is also a little tricky. So you basics might not be enough, but I guarantee you one thing: if you invest your time into preparation and you clear DP100 yourself with your practice, you will know data science like that. It's like that.
All right. So yes, we don't have any more questions now.
Okay, so I
Uh,
think you can carry on, right?
yeah. So thank you so much, Shivam, for all those amazing insights, and I'm sure our viewers out there found the demo very informative as well. So now we'll quickly move on to our Hacknight team, Lannisters. So we have Mayur from Hacknight who will be sharing his story, like how what he built at the Hacknight and how did he build it. So Mayur, can you just please take over?
Yeah, sure. Let me know when you see the screen.
Yeah, sure. Mm. Yeah, we can see your screen.
Cool. So we had built this tool called Deep Specs. So what it does is it is an Android app and it was built for visually impaired people. The idea was to uh, so this is the application. We have an Android app, and based on you have internet connectivity or not, we are using different services, and it would tell the person what are the objects in front of it. So that way, visually impaired people can navigate if they are on a new place. So this way, it is helpful. Now, what we had done is, if you have internet connectivity, so as Shivam described earlier, you have different services available, cognitive services. So we use cognitive services for it.
Mayur, can you just be a bit loud? We're not able to hear your voice clearly. Or you can just check in with your speakers, maybe.
Okay, is it better now?
Yeah, just a bit louder. Okay, all right.
Okay, so we used Azure Cognitive Service. When you have internet connectivity, we wanted better predictions like is it a table, desk, chair, whatever it is in front of it. So we use cognitive services. That way you get better probabilities as it was shown in the previous demos also. And if you're offline, still we would like to let the user navigate. But without internet connectivity, we used TensorFlow Lite, which is there in the Android apps. So we used a pre-trained model which is SSD MobileNet. You can search about it later. So these models comes pre-trained with most of the objects which you would find in your nearby locality. So it's already trained. You just have to call the APIs and it would give you the predictions. And based on the results, we did some CV uh, analytics and found out like is it on the left part of the screen or right. That way we could tell if there's a object in front, which direction is it in. That way the user can navigate. So these were the tools we were using: Android app, then TensorFlow Lite for model building on offline mode, and cognitive services when the person is connected to the internet. So let me just show you. For if you go to azure.microsoft.com, you have something called AI plus machine learning there in cognitive services. You can find in vision there are computer vision APIs available where you give it a image and you make a API call, you would get a response like this. So let's say we take a simpler image, like you have two objects identified. One is a person, if you see, and the other is the skateboard. So you get the objects, also the tags and the location, the bounding boxes of it. So the box that you see. Now, most of you must have seen in the Android apps or any app, camera app which you use, you would have some grid system. Like it would be dividing the whole frame in 9 boxes, right? 9 rectangles. So using that concept, we would, so like if you have a person, the box you have, you divided the whole image in 9 boxes, and from there identify in which of them it belongs to, and that way we could identify the uh, location of the object. Is it left, right, or center? And using the accessibility services available in any mobile phone, we could give speech output also. This was the overall flow. Yeah. So guys, let me know if you have any questions on it. I see. Why to use online if it can be done offline? What is the advantage? Yeah, so offline if you do, so SSD, mobile SSD net works fine, but then there might be cases when the predictions are not so good. So using online services makes better, you get better predictions and better output also.
I guess we're done. So, maybe do you have a demo or something which you would like to show?
I have a video, but I don't think it would give the sound, but I can just tell it what is happening.
Maybe.
Let me know if you can hear the audio also. Can you hear the audio?
No.
Okay, so basically, here it is saying uh, chair left, now refrigerator center, and this way we are navigating in front. So it's continually saying refrigerator front that way, table left. So the audio won't play because it's coming from system. That's a limitation right now. But this is the overall idea. So if visually impaired person has come in a new area which is not known to him, so he finds it difficult to navigate around. So using this app, it's easier for him.
All right. So I guess this pretty much sums up everything now. So, so I guess we are done. Any more queries? No. So thanks a lot for joining everyone. And so like we mentioned, this is a series of webinars. So the next webinar is on 16th May and it would be on getting hands on Azure with the cognitive services. So do join it also and let us know like how was your experience, and do share experience via tweet, and the hashtag is AI in Azure. All right. So thank you so much for joining again, guys. Bye bye.
Thanks, everyone.